Have you ever pondered on the rhythmic language of the universe? Imagine a symphony, a grand orchestration of notes and melodies weaving together to create a beautiful composition. Now, replace the instruments with galaxies, stars, planets, and even the tiniest particles known to man. Each element of this universal orchestra vibrates, producing a unique frequency, a distinct note in the cosmic concert. This isn't just a fanciful metaphor, it's a concept deeply rooted in the scientific understanding of the universe. From the ceaseless dance of atoms to the vast movements of galaxies, everything is in constant motion, creating an ever-changing vibrational pattern. It's as if the universe is speaking to us in a language of vibrations, a language we are just beginning to understand. Like any complex piece of music, this universal symphony begs the question, is there an underlying score, a code that governs these vibrations? If the universe is a symphony, then is there a code to understand its music? In the realm of theoretical physics, there's a melody that strings play. Imagine a world where the smallest particles aren't just tiny points, but rather minuscule strings. This is the fascinating universe of string theory, a theoretical framework that revolutionizes our understanding of the fundamental structure of matter. String theory proposes a bold idea: the building blocks of our universe, particles like electrons, quarks, and photons, are not zero-dimensional points. Instead, they are one-dimensional strings, unimaginably tiny, stretching and vibrating in the vast cosmic orchestra. Now, here's the beautiful part. These strings aren't just aimlessly oscillating. They vibrate at different frequencies, much like the strings on a musical instrument. In a way, you could say that they're playing a cosmic symphony, with each string contributing its unique note to the grand cosmic score. The frequency at which a string vibrates determines its properties. If a string vibrates at one frequency, it manifests as an electron with its specific mass and charge. If it vibrates at another frequency, it might become a photon, the particle of light with no mass at all. It's a profound and elegant idea, suggesting that the diversity of particles we observe might just be the result of different vibrational patterns. Think of it this way: a single piano string can produce different notes depending on how it's played. In the same vein, a single fundamental string can manifest as different particles depending on its vibrational frequency. It's important to note, however, that string theory is still a theoretical framework. It's a beautiful and compelling melody, but we're still learning to play the tune. We're still in the process of testing its predictions, and it's yet to be fully confirmed by experimental evidence. So, string theory suggests that the vibrational code of the universe lies in the frequencies of these tiny strings. The particles that make up our world, and by extension our reality, might just be the product of a cosmic symphony, a grand concert played by the tiniest strings in the universe. Quantum mechanics takes us to an even deeper level of vibrational understanding. At the heart of quantum mechanics is a fascinating principle known as wave-particle duality. This principle suggests that all particles, from photons of light to electrons whizzing around an atom, also exhibit the characteristics of waves. It's a bit like the particle is leading a double life. Sometimes it behaves like a particle, and other times like a wave. Now you might be wondering, what does this have to do with vibrations? Well, when we speak of particles behaving like waves, what we're really talking about are vibrations. These aren't vibrations in a physical sense, like a guitar string vibrating to create sound, but rather, they're vibrations of probability. The properties of particles aren't determined by solid, unchanging characteristics, but by the vibrations of these wave functions. Think of it like a song on the radio. Just as the sound you hear is determined by the radio wave's frequency and amplitude, the properties of particles are determined by the frequency and amplitude of their wave functions. The frequency of a particle's wave function can tell us about its energy. High-frequency waves correspond to high-energy particles, while low-frequency waves correspond to low-energy particles. Similarly, the amplitude of a particle's wave function can give us clues about where the particle is likely to be found. But here's the real kicker. These wave functions are constantly changing, constantly vibrating. This means that the properties of particles and, by extension, the properties of everything in the universe are in a constant state of flux, determined by the ever-changing vibrations of quantum waves. This is the essence of quantum mechanics, a world not of solid particles, but of vibrating wave functions, a world where everything, from the smallest particle to the largest galaxy, is connected through these quantum vibrations. Quantum mechanics, therefore, provides another key to unlocking the vibrational code of the universe. So, how do we crack this vibrational code? Well, scientists around the world are conducting groundbreaking experiments, delving deep into the world of particle physics and making astronomical observations. They're hoping to decipher the complex vibrational language that underpins our universe. Imagine being able to understand the universe as if it were a vast symphony, each note a different vibration, each vibration containing a secret waiting to be unlocked. These efforts to decode the vibrational code could lead to unprecedented breakthroughs in technology. Imagine devices that can manipulate these vibrations or harness their energy. We could witness the dawn of technologies we've only dreamed of. Moreover, decoding this code could give us a profound new understanding of the universe itself. It could answer some of the greatest mysteries of science and provide fresh insights into the nature of reality. Just like deciphering a cryptic symphony, cracking the vibrational code of the universe might be our key to a deeper understanding of reality. As we continue our cosmic journey, the symphony of the universe keeps playing. A symphony, not of sound but of vibrations, echoing through the cosmic fabric. We've explored the role of string theory, painting a picture of particles not as points, but as tiny oscillating strings. Each string vibrates at its unique frequency, contributing to the celestial symphony. We've delved into the realm of quantum mechanics, where the ordinary rules of physics give way to the extraordinary. Here, vibrations exist not only as waves but also as particles, embodying the dual nature of light and matter. And we've looked at the tireless scientific endeavors to decode these vibrations, to crack the code of the universe. From theoretical physicists to quantum scientists, the pursuit of understanding is relentless, a testament to our innate curiosity and resilience. While we may not yet fully understand the vibrational code of the universe, every discovery brings us one step closer to comprehending this cosmic symphony.